Welcome. This video is going to cover exercise 453 for my engineering mechanics students, where we have to determine the moment of the force F about an axis extending between A and C and express the result as a Cartesian vector. So we have the force vector. Now we also need a unit vector to represent the axis of interest, which is the axis extending between point A to point C. Another quantity we're going to need is a position vector that points from any point on the axis of interest to any point on the line of action of the force. So for instance, the easiest one to probably do here is to draw a position vector that goes from point C, which is on the axis of interest, to point B, which is really the only point we can determine on the force vector, its line of action. So we'll find RC to B, but note, you could also use RA to B. It's just that that position vector is going to be a little more complicated than just doing RC to B. But as long as it's from any point on the axis to any point on the line of action of the force, we're good. We already know the force vector in IJK, so let's find the unit vector representing the axis of interest UAC. So we find that unit vector by taking the vector r from A to C, the position vector, which turns out to be 4i hat plus 3j hat plus 0k hat feet. And then we divide by the overall magnitude, which turns out to be 5 feet. So the overall unit vector to represent that is going to be 0.8 I hat plus 0.6 j hat plus 0 k hat. And there are no units because it is a unit vector. So I am just going to write the force down again here a little bigger, so I'll put it right underneath that unit vector. And then the final thing we have to find before we start doing calculations is that RCB, which is actually pretty easy because it's just in the negative k direction. It is negative 2 pounds k hat. Whoops, I actually got if you're watching this, I'm narrating, I got the quantity wrong. RCB should be in feet, not pounds. That's my mistake. I apologize for that. I will have to fix that in a later edition of the video. Okay, now to find the moment of the force around axis AC, we're going to have to use the triple scalar product. So we're going to have to take that unit vector AC and do the dot product of it with the cross product of RCB cross F. Now, we're lucky here that we can do this in one matrix. So I am going to set the top row to be the UAC, so 0.8, 0.6, and 0. I am going to set the middle row to be RCB, and that's 0, 0, negative 2. And of course, the bottom row becomes the force vector, which is 4 I hat, 12 j hat, negative 3, and in pounds. So they have to go in this order in the matrix. And then you're going to find the determinant. And I'm just going to go through the calculation here. Please see, in other videos, we go over how you go about doing the cross products and types of things on the calculations. So I'm just going to plug in the numbers quickly here. The main thing to note is there are no I hats, j hats, or k hats now. The idea of a triple scalar product is that you get a scalar out, which is just a quantity, a number, a magnitude. So you're not actually having any I, j, k, or other vector notation. And the overall result when you add it up is you get 14.4 pound feet. And that's the answer. So the moment of the force around axis A to C is 14.4 pound feet. Now, the other thing you can do with this is you can actually convert it into a vector form. You're just going to take that magnitude, that 14.4 pound feet, and multiply it by UAC. That will give you the moment along AC in vector format. And you can see I'm just doing that up on screen now. And you end up with 11.5 I hat plus 8.64 j hat plus 0 k hat pound feet. And that's the answer to this question. As always, if you're having any problems or want to ask any questions about this, please get into contact with me. I'm happy to help in any way I can. Other than that, I would like to thank you for watching, and I hope you have a great rest of the day.